lecture we have seen capacity of a parallel plate condenser. That formula we have derived. C is equal to A epsilon 0 upon D. And if there is a dielectric medium, then we can say that C is equal to A epsilon 0 K upon D. Now, if such capacitor means parallel plate capacitor, if such parallel plate capacitors are connected in series, so what will be its equivalent capacitance? That we are going to see in this lecture. So now capacitor means parallel plate capacitor, so it consists of two plates. So this I can say that, let's consider this is the first capacitor having capacity C1. Here is the second capacitor having capacity C2, and here is the third capacitor having capacity C3. Now capacitors are connected in series means what? The consecutive plates of capacitors are connected to each other. Now this is the first plate of the capacitor where charge Q is deposited, so plus Q. Therefore, according to concept, minus Q charge will get introduced on the second plate, neighboring plate. C2 capacitor, again charge deposited is plus Q, neighboring plate minus Q. C3 capacitance, charge deposited is plus Q, neighboring plate minus Q. And such series combination of the capacitor are connected across a certain battery potential as a V. So now what we are getting here? When capacitors are connected in series, the charge deposition on each plate will remain same. Now why it is so? This battery will send the current, and that current will give the charge, and that charge will get deposited on each capacitor. So the same amount of charge will give same amount of electron to get deposited. So the charge on every capacitor will remain same. So this is one first important point. That is, when capacitors are connected in series, the charge Q deposited on each plate will remain same. Now what is next? We are knowing that capacity C is equal to Q upon V. This formula we have seen in the previous lecture. Now if I am considering first capacitor C1, so this formula I will replace C1. Charge deposition is charge Q. So corresponding potential I will say as a V. Now that V potential I can show here. Here is the deposition of developed potential is V due to charge Q on C1. Similarly, I can say that on C2 developed potential is V2, and on C3 the developed potential is V3. So for C2 I can write formula C2 is equal to Q upon V2. Similarly, I can write on C3 is equal to Q upon V3. So now from this, what is our observation? That is, your battery potential V will get divided as a V1, V2 and V3. Therefore, now we can write the next important point. That is, in series combination, total battery potential V is equal to V1 plus V2 plus V3. Now we can substitute value of V1, V2 and V3 from this formula. So now from this first formula, I can get V1 is equal to Q upon C1. Now that formula I can substitute here. So instead of V1, I can write down Q upon C1. Similarly, for V2, from same formula I will get it Q upon C2. And for V3, I can get Q upon C3. In that, this Q factor is common. So I can say that Q, V is equal to Q factor common inside the bracket 1 upon C1 plus 1 upon C2 upon plus 1 upon C3. This Q factor I will take for division. So I will get the next important formula as here I'll write down. I'll get it. V upon Q can be written as 1 upon C1 plus 1 upon C2 plus 1 upon C3. Now this V upon Q. For this V upon Q, V is the total potential. Q is the total charge deposited. This V upon Q, I can write down 1 upon Cs. This Cs is nothing but the resultant series combination capacitor. So I'll write 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Now this, in series combination, we are getting this formula. Therefore, the resultant capacitance in series combination will always goes on decreasing. Because here I am getting 1 upon Cs, that is reciprocal. So the resultant series combination capacitor always goes on decreasing. Now, if instead of these 3 capacitors, if I am going to connect the number of capacitor as a n capacitor, then what I write? 1 upon C1 plus 1 upon C2 plus 1 upon C3 up till 1 upon Cn. And if capacity of each plate is same, means C1 is equal to C2 is equal to C3 is equal to up till Cn, then this formula will get reduced into, I'll say 1 upon Cs can be written as n upon C. And therefore simply Cs can be written as a C upon n. Means in series combination the resultant capacitance will goes on decreasing. So this is about your capacitors in series combination. So what are the important points here? Capacitor in series combination, charge will remain same. Potential on each capacitor is different. Next, the total potential is nothing but the summation of individual potential developed on the capacitor. And last point is equivalent capacitance. Reciprocal of equivalent capacitance is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. And from that we can conclude that the resultant capacitance in series combination will always goes on